Okay, hello everybody. My name is Allison. I'm one of the developers on our team. And I'm here to tell you a little bit about KBboard, an online Kanban web application we built from the ground up. The following key discussion points will be addressed, including a web demonstration of the app and its primary features, as well as an overview of how we approached designing, building, and deploying it. So what exactly is Kanban? It actually means visual signal or card in Japanese. The Kanban system was originally invented by Toyota as a visual signal for better task management. Today, the Kanban methodology is used not only in production or factory environments, but also in software development and even a small personal project. It's all about productivity, which is what we value. Therefore, allow me to introduce to you the KBboard, a fast and simple way to make your online Kanban board. Now you may ask, there are already so many products on the market. What kind of problem are we trying to solve? What is our motivation? Now, taking Jira as an example, it's so great and so powerful, but just like other similar products, they're often enterprise focused. If I were to give an example of a user persona, let's imagine a non-tech savvy relative who wants a simple Kanban app to manage the shopping task for the coming Christmas. Is he or she going to use Jira? Probably not, right? The complicated user interface and overwhelming features are just not suitable for a scenario like this. Here's what we are going to offer you: a minimalist, user-friendly, and super easy to use online Kanban board for your daily errands and small projects. Let you focus on being productive instead of busy. In our phase 1 development, we completed the MVP building, which include the following features. The app is accessible to all, completely free, and doesn't require any time-consuming setup. With simple registration, you gain access to your very own Kanban board and can begin management tasks right away. You also have the option to specify a delivery point for time-sensitive tasks, assign a priority tag, and indicate the effort required. We built the app with popular MERN stack, which representing MongoDB, Express, React, and Node.js, and with the support of additional frameworks and libraries. It used JavaScript and JSON to construct a 3-tier architecture covering our front-end, back-end, and database. As for deployment, our DevOps team will elaborate more in a moment. Now, the reason we used MongoDB for our database is due to its scalability. The power of document-oriented database is that the documents can be retrieved directly in JSON format. Because JSON has a flexible and dynamic schema, adding fields or leaving a field out is not a problem. Consider that we will build more features in phase 2 development. MongoDB really offers the kind of flexibility we need. Now, before our demo, let's have a look at the user flow for the main function. When a user visits our website, the user has the option of signing in or creating a new account. If the credential is valid, the user will be taken to the project page, where you could create a new project, continue on your existing project. From there, you'll be taken to the Kanban board page. The setup involves just a few clicks, and you're now ready to start managing your task. Let's have a look at the web demo. What you're now seeing right now is our homepage. Signing up is pretty straightforward. Click on the sign up button and fill out your personal information. Next, signing into your account with your username and password. You're now looking at the project dashboard. Let's say we want to create a new demo project for building an online Kanban board. Remember, you can create as many projects as you want, whether it's for your work, personal life, or Christmas shopping. Now, select the Kanban board, the project, and this is your board page. Let's create 4 columns: to do, in progress, done, and archive. And then create your task. For my first task, I would like to do some research, for example. I also want to set a due date and label it as a standard task. It's not too difficult, so I will give it 2 as an effort point. And now I'll do the same thing for my second task, which is planning. And this time, I'll set this task as an urgent task. As you're making progress for your task, you can move them accordingly. Once you're done, once you're done, you can delete them all at once. You also have the option of customizing your profile. And finally, click log out, and we're back to the home page. I'll now hand over to my DevOps team to talk about deployment. Can someone mute your mic, please? Jason?
Hello, everyone. My name is Chantal, and I am one of the team members in our DevOps group. Our group also has Jason, Sherry, Sean, and Shane. I will introduce our DevOps architecture in our project. In our architecture, the front-end code will eventually be automatically deployed to the S3 bucket. The back-end code will be put into ECR and allow customers to access a container database and image through ECS. All the users of KBboard can access the website through CDN, which is Content Delivery Network. Unlike the traditional web hosting, that all users from different regions must send requests and get response from the only single original server. CDN uses a group of cache servers located all around the world, which can provide much faster delivery of website content to end users, then can reduce lengths significantly. When the user enters a specific URL, the URL will guide the customer to the IP address we set through route 53 and display the website content stored in the S3 bucket. The web has been accelerated by CloudFront to provide users with a better experience. When users use our product, they sometimes need to use backend data. This data are safely stored on MongoDB Atlantis virtual private cloud and connected with our virtual private cloud in AWS. Users will access through Internet Gateway. We create 3 availability zones. The users required will first enter the public subnet. Application load balance will load balance this as censuses. Important and highly confidently files are stored in the private subnet and connected to the outside world use NAT gateway. This allows instance in the private subnet to connect to the service outside the VPC, but the external service cannot connect it to those instances. In subnet, we deploy a Fargate outlet to flexible adapt to the requirements of the web page for containers and computing volume. In the monitoring part, we use CloudWatch to do the monitor. We use Grafana for visual display and use Amazon Simply Notification Service to notify relevant personnel. We also create a backup for the product. In this architecture, we use Kubernetes to manage related containers and add tools such as Argo CD to improve efficiency. Next, Sherry will go to introduce our CI/CD and pipeline.
Hi, I'm Sherry. I'm here to introduce you with continuous integration and deployment tool we use for our project. We configured a multi-branch pipeline using Jenkins. Every time developers push their source code into Bitbucket repository, the pipeline will be triggered automatically. If it's from the features branch, the source code will be built and sent to SonarQube for code quality and security check. And if the code is from the main branch, the pipeline will do the whole progress, including build, test, and deployment altogether. The automated deployment will always be to the UAT environment in our project, and all the features and the functions will only be deployed to the production environment manually after 100% assurance. Our team can get immediate notification if there is anything wrong with the code, and the symbol of failure or success will appear immediately on the user's interface after pushing code. Also, the developers can check with the status and the problems via Jenkins pipeline's log to adjust their code accordingly. And because the multi-branch pipeline will check with any changes made to a repository continuously, so our team can find problems very soon. The pipeline pushes the whole project, keep forward, and ensure continuous high-quality code delivery within a very short period. And that meets the principle of agile methodology, which help our team move faster with fewer problems. The static content of a front end will be sent to S3 bucket, and it's a very safe and a cost-effective storage on AWS, which also enables auto-scaling, and users can get access via CDN, which can reduce latency significantly. Our team member, Sean Lee, will introduce more tools that we use in the next part of backend CI/CD pipeline. Let's welcome.
Thank you, Sherry. Hello, everyone. My name is Sean Lee. I'm going to introduce our backend CI/CD pipeline. When developers push and merge code into Bitbucket, Jenkins will trigger code by Jenkins file, and following stages automatically to build backend application as a Docker image, and push it to ECR, which is Elastic Container Service in AWS. After uploading to ECR, ECS and EKS will pull the updated image and set up the application. And also, we set up SonarQube, integrated with the Jenkins pipeline for collecting, analyzing source code, and providing reports of code quality. If the source code has potential risk or is below quality standards, the developers will be informed immediately to check their code. And also, we create different groups of users in SonarQube as needed, and attach them to access projects, services, and functionalities. Automated code review and coding standards check can ensure high quality codes and safety control. And also, we use Trivy for our security purposes. Trivy can scan security issues and misconfiguration for the container image before being uploaded by Jenkins to ECR automatically. And we set up Trivy in a Jenkins pipeline stage, which is also part of our automation process. In terms of the diagram below, we will get a brief overview of how the CI/CD pipeline works. It is a logical demonstration of how applications move along pipeline stages in lifecycle before being delivered to UAT and the production environment. That's all about our pipeline. Now I'm gonna hand it over to Jason.
Hello everyone, I'm Jason. I will talk about how we use Terraform to provision and manage our cloud infrastructures. We use Terraform to write our infrastructures as code. Every time we deploy the infrastructures, it will be exactly the same. On the contrary, manually deploying is prone to errors. In order to prevent multiple developers accessing the state file at the same time, we use a S3 bucket to store our Terraform state file remotely and a DynamoDB to set the lock and unlock state. Terraform state file represents the current infrastructures on the cloud, and it contains many sensitive information. Therefore, we need to encrypt it while storing it on S3. This is our folder structures. It consists of application and modules. The use of modules allows us to group resources together and reuse it as many times as we want. This helps making our code much cleaner, easy to read, and improve our efficiency of writing Terraform code. Also, we use Bitbucket for our version control management. There are a number of benefits such as tracking modification and keeping a complete history of the code. In addition, it makes it easy to roll back to a previous version when necessary. Moreover, teams can collaborate better and accelerate the development process. That's all for Terraform. Now Shay will talk about monitoring and logging.
Hi everyone, I'm Shay. In the monitoring part, we use the Amazon Managed Grafana for data monitoring, data statistics, and set up the alarm function to manage the data. At the same time, we use ELK to troubleshoot applications and analyze service behavioral data. In the Grafana, for Amazon EC2, we can see these aspects of different instances by different colors, which are overview, CPU utilization, disk details, network details, and the status check. Compared to different days of some CPU utilization, we can observe which instance increased and the instance churn rate. For altering of Grafana, we can see the different status by different colors, like OK, pending, and altering. We can get the notifications by raw conditions, data, and error problems, then check the notification and logins to manage the data. Compared to the Amazon Grafana and Amazon Cloud Watch Logs, Grafana has more service data source and rich data dashboards, which can make operation and maintenance monitoring more refined. The specific process we use ELK is that the login process starts with the transfer of events into Amazon Cloud Trail. Then the file bits in Trail is transferred to S3. The file bit queue is processed in Amazon SQS and transferred to bits. Finally, the data is analyzed using Kibana in ELK. After these processes, we can observe the CPU usage, node, memory usage, and network traffic. We can get the more information and details by using different functions and filtering requirements. Through the visualization function of Kibana, the data is converted into different kinds of charts, making it easy for users to read and analyze data chains, allowing users to easily understand big data, and we can get more details and information in these pictures. Then hand back to Alison. She will talk about more details.
Okay, thank you, Shay. As developer, we are, sorry, just give me a second. Okay, as developer, we are always learning and self-reflecting. We want to know how can we do better. We really thought about this. So first of all, we could have a better planning at the beginning by having a more detailed plan, a more clear data structure to really reduce the communication workload at a later stage. In a situation where we don't have a BA and UI UX, what can we do is to get 1 or 2 developers to take over the responsibility, the ownership of this part, quickly learn the basic concept so we could improve the overall efficiency in the agile environment. And upon reflection, we actually planned for our phase 2 development. We would like to know how to build the app in a better way. We'll seek advice from experienced developers, professionals, and learn from the best. Additional features will be added as well, such as team collaboration, quick filters, work in progress limit, and some visual metrics. Finally, I'd like to thank all the team members for your amazing work. Despite all the challenges, battling COVID and reduced team members, we didn't give up. We stick to the end, so thank you very much. And hopefully we will continue to collaborate and improve this product together. A special thanks to our tutors, Billy, Olivia, and Kitman. We value your support and time and want you to know how much we appreciate you for being there for us. So thank you very much for listening. That's the end of our presentation.